All right, let's go for the test of independence. Hey, I realize you guys are hearing. I've got a neighbor who's got out some kind of big circular saw or something. I wasn't sure if you guys could hear that in the background. It is loud for me, but sometimes that stuff doesn't come through. I listened to the last video, and that definitely comes through, right? So I apologize for that. Okay, the test of independence. What is this? This test will decide if two variables are related. The variables are always assumed to be independent. And so there must be enough evidence that they are actually related. All right, so we're going to see is one characteristic related, or one variable related to another. And it might seem really clear, to us at first, like, of course these are related, but can we show it to be statistically significant? That's a whole nother issue. And you notice we always assume that they are independent. In other words, we assume they are not related. So we need evidence that they actually are related, that one influences the other somehow. Okay, so take a look. It says a contingency table of the two variables will be given. You guys remember contingency tables from earlier in the semester. So we're going to be provided that. The test statistic is still, we got the same formula. It's still the sum of the observed minus expected squared over the expected. But now the expected value of each category is this. And now we've got this formula just for how to calculate the expected value compared to the observed values. And of course, we'll talk about this in the example, but it's going to be row total times column total divided by the total number observed, and that's speaking to the contingency table. Okay, so more on that in a moment. For the p-value, now this is different too. The way you do the p-value, the degrees of freedom changes. It's no longer simply the categories minus 1, but it's the row categories minus 1 times the column categories minus 1. All right, here we go. Practice number 3, let's see what this is all about. It says the San Diego Community College District conducts a study to see if a student's anxiety level is related to their college GPA. A sample of 200 randomly selected students across the district are surveyed, and they came up with this table. So they asked people, what's your anxiety level, high, medium, or low? And then they asked, what is your overall GPA? Is it between 3 and 4? Between 2 and 3? They just had those two categories to pick, and then they totaled them. So they got the total for each anxiety level. They got the total on the right for the GPA, and then the total of totals down there at the bottom. And that's your 200 people that they surveyed in all. Okay, wow, a lot of information there. And finally, it says at alpha equals 0.01, can the district conclude that anxiety level and GPA are related? Hey, there's no doubt a lot of people have high anxiety, but is that connected somehow to their GPA? You might think, well, if a student has a low GPA, they might be more anxious. That's true. But also, people who have high GPAs are very anxious because that anxiety, maybe drives them to that higher GPA. I don't know. Maybe they have higher GPA because they're going into more something really competitive. They're trying to transfer, get to the next level, and that's very stressful. Okay, let's take a look here. How are we even going to begin? Okay, well, of course, we start with our null and alternative hypotheses. So step number 1. Remember that we always assume that the two variables are not related, that they are independent. So here's step 1, the null hypothesis. Anxiety level and GPA are not related. That's always going to be the case. We state your two variables and say these are not related. Or you might use the language they are independent. Okay. Well, what is the alternative hypothesis then? Well, it's simply the opposite. that they are related, right? So H1, anxiety level, and GPA are related. Or you might use the word dependent. Okay. Again, assume they're not related. So the alternative is always going to be that they are related. We need a lot of evidence to show they are related. Okay, very nice. Now, when it comes to the test statistic, next. This is definitely the new aspect, right, to learning any new hypothesis test, and that is definitely going to be the case here. So what's happening? When we calculate our test statistic, we need to create an expected table. Okay, so we've got observed and expected. The observed, I'll just tell you here, the observed are the numbers you see in that table that is provided. So we observed there were 60 students with both high anxiety and a GPA between 3.0 and 4.0, right? We observed 60, right? We observed 35 students with medium anxiety and a GPA between 3.0 and 4.0. Okay, those are all the observed. You can ignore, when it comes to the observed, you can ignore the totals around the edge. We just look at, the intersection of those categories. So how do we find the number that we expect for each one of those, pairings, right? How many students would we expect have high anxiety and a GPA between 3.0 and 4.0? How do we do that? Okay, and that's where this formula comes in. I'm going to, you know what? Let's go with this. So I've got the numbers filled out. I'm going to show you how we calculate these, and we'll just kind of talk about that on the side. Okay, perfect. So you notice we're recreating that contingency table, but we're leaving off the totals around the outside edge. So we've got high anxiety, medium anxiety, low anxiety, and the GPAs between 3 and 4, between 2 and 3. Okay, so the numbers we see in the table they give us, that's the observed. This turns out to be the expected. Now, how did I calculate this? With that formula, right? So let's say we're looking here. Now, let me just erase it for a moment. We're looking at high anxiety, GPA between 3 and 4. So what we're going to do, what the formula says, is do the row total times the column total divided by the total number observed. So to fill this out, sorry for that saw going on in the background. Wow. This is like key moment in the lecture, and that's when the saw kicks in. Okay. All right, so we're going to, so find this location in the table they give us, right? High anxiety and GPA between 3 and 4. So we're going to look at the row total. The row total is 115, right? That's the total number between 3 and 4 GPA. We're going to multiply that by the column total. So the column total for high anxiety is 90. And we're going to divide that by the total number observed, which was 200. And that's going to give us 51.75. That's how we fill this in, 51.75. We're going to do that for each of the 6 possibilities. So maybe let's do it again for the medium anxiety, so you see it a second time. Medium anxiety, so I go to the table there that they provide. What's the row total? Medium anxiety with 3 to 4 GPA. So the row total, well, it's 115 again, right? Because that's still the same GPA. What's the column total for medium anxiety? 55. And we divide it by that same total of 200. Gives us 31.625. So that's what we fill in. Okay. Be sure, I recommend go through each one of these and get the same numbers as me, right? So low anxiety and GPA between 3 and 4. So the row total is 115, the column total is 55. 115 times 55 over 200. Turns out it's the same numbers we just had here, so that number turns out to be the same. And then you can see the rest for the GPAs between 2 and 3. Again, row total times column total divided by the total of totals. And you'll fill in each of those 6. All right. What do you do once you have this expected table? Well, these are the expected numbers. The numbers they give us are the observed, and we're going to go through that same procedure. So now we do our big table. Oh, yeah, there's our formula. Okay, and be sure to mention that. Write it on the page. Now we go to our big table, where we do the O and the E, and then O minus E squared over E. All right. Now, when we begin our big table, you're like, oh my gosh, there's 2 tables happening here. Yep, so we got the expected table, and then we go to our big table to calculate and then finally add them up. When you create your big table, you'll have to think, how many categories are there? All right, because we have rows and columns, there are 6 categories. 3 across the rows, 2 down the columns, so that makes 6 categories, right? So for instance, high anxiety and GPA between 3 and 4 is 1 category, and each pairing, right? So when we create our big table here, there's 6. 1, 2, 3, 4, 5, 6. High anxiety and between 3 and 4. High anxiety between 2 and 3. Medium anxiety between 3 and 4. Medium anxiety between 2 and 3. Low anxiety between 3 and 4. Low anxiety between 2 and 3. They each get their own column. Okay. Once we have that all set up, let's go ahead and fill in the observed. Again, the observed is from our data, right? That's from the sample. So that is the contingency table they gave us in the problem. I ordered these this way with high, high, medium, medium, low, low. You might change these, change the ordering. It doesn't matter. So long as they're all there, the ordering, maybe you put this one in the second position. That's kind of how we were reading it a moment ago. That's totally fine. It's all going to work out to be the same test statistic. But now when you fill these in, just be really careful you're doing it right. So high anxiety between 3 and 4 is 60. High anxiety between 2 and 3 is 30. And then 35, 20, 20, 35. It's easy to mix stuff up because there's just so much information. Okay. Then we use our expected. And now these numbers are all of the numbers that we calculated, right? So I've got 51.75, and then high anxiety between 2 and 3 was 38.25, right? And we've got all of those numbers. I'm just double checking them now. Those are the expected numbers. By the way, I didn't say this a minute or two ago, and I should have. If you're wondering where this formula came from, I did not want to take the time to do it in this video. So if you are wondering where this formula came from to calculate all of these expected values, it actually goes back to our chapter on probability, chapter 3. But again, I'm not going to go into the details. It's pretty interesting, though. If you're curious, definitely talk to me, in office hours or something like that, and I'll tell you where this came from. It's pretty cool. Okay, so we fill those in, and then we go through our same steps, right? Observed minus expected squared over expected. Now here, you're going to have all these decimal places. That's just the way it is with the test of independence. Don't bother with any fractions. It's just too crazy. Round these, and it appears I rounded these to 3 decimal places. Okay, fine. I think that'll work. No problem. So, if we do this first one for this first column, right? Same idea, 60 minus 51.75 squared divided by 51.75. And that will give us 1.315 when we round 3 decimal places. That works. make sure you can calculate all these same numbers that I just got. And what are we going to do with that? Now things are looking more familiar, right? We're going to add these up. Add up our 6 different values for our 6 categories. When you add those together, I got 13.995. This would be fine if we called our test statistic 13.995, but I like to round it to 2 places. So when you round, well, that 5 rounds this up and you end up with 14.00. It's not going to make a difference in the answer. If you go to 2 decimal places, no big deal. But if you want to be a little bit more accurate, 13.995 would work. Okay, from here, well, it's really going to be the same as what we saw in the previous problems. Oh, I take that back immediately. The degrees of freedom has changed. Okay. All right, degrees of freedom. How are we going to find that? Okay, remember it's row categories minus 1 times column categories minus 1. How many row categories are there? There are 3. No. Oh my gosh, wow. I just threw my... The rows go down, right? There are 2 row categories. There's GPA between 3 and 4 and GPA between 2 and 3. Okay, don't count the totals. If you look back at that original contingency table, that doesn't count, right? Kind of almost like you want to look back here. There are 2 rows. How many column categories are there, right? High anxiety, medium anxiety, low anxiety. 2 row categories, 3 column categories. So there we go. 2 minus 1 times 3 minus 1. Well, that's 1 times 2. So our degrees of freedom is 2, which is it's a really small number of degrees of freedom, but yep, that's how it's calculated. Just accept it. All right, so now we can go to our chi-square calculator in StatCrunch, and hopefully you can get this right. We use the greater than. I'm going with 14.00, and I'm going to round that to 4 places. So I got with 2 degrees of freedom, so I got 0.0009. Okay. We're almost there. Let's compare that to our alpha. Well, 0.0009 is less than our alpha of 0.01. Again, we got that 0.01 for alpha. Okay, well, we still got smaller than, right? And so, because our alpha is bigger, we reject the null hypothesis. And if you're thinking about an interpretation, of course, we say there is enough evidence. There is enough evidence that what? Well, we just repeat that alternative hypothesis. There is enough evidence that anxiety level and GPA are related. Maybe that does not come as a big surprise. Our data backs it up. That is strong evidence too, 0.0009. That's pretty good. There is enough evidence that anxiety level and GPA are related. Hey, that's the end of the chi-square hypothesis test. It's been a lot of fun. Go check out the homework.